Motion in two dimensions, projectile motion. Definition of projectile motion. If force of acting on a particle is oblique with initial velocity, then motion of the particle is called projectile motion. Then assumptions of projectile motion. Air resistance is not considered, Earth is considered as flat, Earth does not rotate, and acceleration due to gravity is constant. Then horizontal motion and vertical motion. These two motions take place independent of each other. While calculating horizontal components, we have to consider only horizontal components. And while calculating vertical components, we have to consider only vertical components. If we want vertical displacement, then velocity and acceleration should be vertical. If we want horizontal, then we have to put horizontal velocity and horizontal acceleration. Time is same for both horizontal as well as vertical. Then types of projectile motion: oblique projectile motion, horizontal motion, and projectile motion on inclined plane. This is oblique projectile motion, horizontal projectile motion, and this is projectile motion on inclined plane. Then equation of trajectory. Equation of trajectory is relation between x and y. Projectile is projected from this point, then it follows this dotted line path and reaches this point. So projectile comes from this point to this point after time t, and coordinates of this point are x and y. Angle of projection initially is theta. Okay, then we have to find out relation between x and y. So we will find out first horizontal displacement. Displacement is what? Ut plus half at square. So displacement is x, therefore s we have written as x. We are writing this equation for horizontal components, therefore u should be horizontal. U cos theta is horizontal velocity, and u sin theta is initial vertical velocity. U cos theta into t. Acceleration horizontal is 0, therefore this part is 0. Then y. Y is what? Vertical displacement. Therefore s is replaced by y. Vertical velocity is u sin theta, therefore u sin theta into t. Plus half into acceleration is minus g, because it is in downward direction, therefore minus g into t square. This t is substituted from this equation, x upon u cos. And after substitution, this equation is called equation of trajectory. We can calculate displacement of projectile, instantaneous velocity, change in velocity, change in momentum. Then time of flight. Time of flight t is equal to 2u sin theta upon g. What is it? 2u sin theta upon g. What is it? 2u sin theta upon g. Then range. What is the formula of range? This is oblique projectile motion. This is oblique projectile motion. Range is what? U square sin 2 theta upon g. What is it? U square sin 2 theta upon g. This 2 goes into the index, and there comes another 2 in front of theta. And what is the height? Height is u square. This also becomes square, and 2g. U square sin square theta upon g. Maximum height reached. Maximum range is at 45 degree. If projection is at 45 degree, range is maximum. Then for theta and 90 minus theta, range is same. Angle made by point of maximum height with the initial point is phi. Then relation between phi and theta is tan phi is equal to half tan theta. Then maximum height u square sin square theta upon 2g. We have seen this already. Then energy of projectile. Energy of projectile at any point in the flight is always constant. Always energy of projectile is constant. Potential energy may get converted into kinetic, or kinetic may get converted into potential, but total energy is always constant. At starting point, kinetic energy is maximum. As projectile moves in upward direction, its kinetic energy decreases and potential energy increases. But always summation of kinetic and potential energy is same. Then T1 is time of flight for angle theta, and T2 is time of flight for angle 90 minus theta. For both angles, range is same. For both angles, range is same. So what is T1 upon T2? What is it? Tan theta. T1 upon T2 is tan theta. Then what is T1 into T2? What is T1 into T2? T1 into T2 is 2R upon G. What is it? 2R upon G. Then projectile path is like this. Projectile takes time T1 to reach this point and time T2 to reach ground from that point. T1 to reach that point and to reach ground from that point it takes time T2. Then height of this point h is equal to what? It is G T1 T2 upon 2. What is it? G T1 T2 upon 2. Then again projectile, again this is the path. At the same height there are 2 points. At the same height there are 2 points. Till this point time required to reach is T1 and till the second point time required to reach is T2. Both points are at same height. To reach this point takes time T1, to reach this point time required is T2. So again relation between h and T1 T2 is same, G T1 T2 upon 2. Then again this is the path of the projectile. Time difference between these 2 points is T1. Time difference is T1. Means projectile takes time T1 to reach this point from this point. Projectile takes time T2 to reach this point from this point. So what is the relation between T1 and T2? It is T2 square minus T1 square is equal to 8h upon G. T2 square minus T1 square is equal to 8h upon G. What is h? H is what? H is height difference between these 2 points. Height difference between these 2 points. Then when range is maximum, what is the height? Maximum height. When range is maximum, what is the height? It is R max upon 4. It is R max upon 4. Then horizontal projectile motion. Equation of trajectory. In this case, projectile is projected with only horizontal velocity, no vertical velocity, only horizontal velocity. So initial vertical velocity of projectile is 0 and projectile comes like this. Then after traveling for some time t, projectile comes to this point. Coordinates of this point are x and y. Therefore we can write x as ut. We are using again same equation. Which one? S is equal to ut plus half at square. But in horizontal direction no acceleration, therefore this part becomes 0, only ut part. Total velocity is in horizontal direction. Then vertical displacement y is equal to what? Ut, but vertical velocity is 0, therefore this part becomes 0. Half acceleration is minus, therefore minus g, and t square. This t we have put from this equation, x by u. So x square by u square is y. Then in this projectile motion also we can calculate displacement, instantaneous velocity, the change in velocity, time of flight. Time of flight is what? Root 2h upon g. Time of flight is root 2h upon g. Range is what? U root 2h upon g. U into root 2h upon g. Then there are 3 balls. One ball is dropped from this height. Initial velocity 0. One is projected with velocity v2 and one is projected horizontally with velocity v1. Then all balls reach ground at the same time. Time required for each one to reach ground is same. Then vertical velocity of all of them when they reach ground is same. And trajectory of A and B when seen from C is straight line. With respect to C, trajectory of A and B is straight line. Then there are 5 balls. First one is projected with upward velocity u, second one is projected like this, third one like this, fourth one, fifth one. All of them projected with same velocity but in different directions. but when they reach ground, their final velocity is same. Total final velocity, not vertical or not horizontal. Total final velocity is same. Ball E takes least time to reach ground and ball A takes maximum time to reach ground.